We're on page 6, and we're looking at the greatest common factor. And how many of you have ever heard of the term greatest common factor? And so you're like, oh no, I've heard it.
Gcf.
Greatest common.
Gcf. That's the order of class.
What's the flags?
The greatest common factor.
Okay, so greatest common factor, I'll refer to it as GCF. For short, you can do the same, but we're talking about that throughout our lesson. And does anyone remember what the GCF even is? So what is the greatest common factor? What does that mean? Can anyone maybe help me out? And it's easy to mix up LCM and GCF, which we'll talk LCM tomorrow or the next day.
Least common factor.
Least common multiple. Mm-hmm. What do you think? GCF, what is that?
Isn't it like if you're doing multiplication, the highest they can get where...
It's tough, yeah. It's like, wait, I can figure it out maybe, but I don't know how to explain it, or I don't even know what you're talking about. So, Alex, what do you think?
I don't know. It's kind of, I feel like I remember doing it.
Uh-huh.
You like two numbers and then you multiply them until one number equals the same as the other number.
Okay, so I think you're starting to think of LCM. Yeah, and that's okay. These are tough concepts. Good thing we review them. You review them every single year, by the way, because it's.
LCM is like taking two numbers and multiplying them to get the same number.
Yeah, and that's kind of thing, and that's the least common multiple. Mm-hmm.
So GCF.
Yeah, what's that?
I mean, is it?
I'm listening. You're getting there, Sam. Yeah, we're going to do some division today. That'll help us out. Jack, did you want to add? Okay. And maybe when we go over it, you'll be like, oh, yeah. Or, yes, I remember doing that. Or maybe after we do it, I still don't remember that. And that's okay. We'll hopefully get this down today. So, the GCF of two or more numbers, so we're talking about comparing two numbers or more, two or more numbers, is the largest number. So the greatest common factor is the largest number that is a factor of those numbers. So when you have two numbers, the greatest common factor is the largest number that is a factor of those two numbers. And you're like, wait, didn't you just say, okay. I like GCF because the name says it all. I'll let you write this down, then I'll explain what I mean by that. Okay, 3 words in this term. Greatest common factor. Does anyone need an explanation of what it means to be the greatest? That means you're like the largest of a group, the largest of a set of numbers. So that's greatest. Common. Help me out. What does it mean to be common or to have something in common? What does that mean, Brad?
Kind of like, not like,
like
appears a lot.
Okay, we have a lot in common. So look at your neighbor, the person sitting next to you, and some of you are like, we have a lot in common. We both wore blue. We both wore red. We both wore white. Some of you are looking at your neighbor and saying, there's nothing in common. Got nothing in common. Nothing. Mr. A, let me make it clear. Nothing. But you do have something in common. The greatest thing you all have with your neighbor, and I can say this for all of you, probably the greatest thing you have with your neighbor, all of you, would be that you're in this class. You're like, okay, fine, get it. Some of you may be good friends. Some of you, hopefully, if I plan this right, I don't know if you're best friends. Anyone best friends? Neighbor? Okay. Man, I didn't plan this right. I didn't sit best friends next to each other. Okay. So when we're talking about numbers, we're talking about the greatest common, what they share in common, what they have that's the same. And then that word factor. I need to know what a factor is, because if I don't get a factor, I don't get greatest common factor. Like I get greatest, I get common, I don't get factor. What's a factor? And then silence overwhelmed the crowd. Okay, yeah, Alex, what do you think? Factor.
It's like a number that can go into
Another number? Okay, yep, you could say it's a number that goes into another number. Whenever you see factor, guys, think of this operation automatically. Multiplication. It's just a number being multiplied. So can I give you a math fact? Ready? 11 times 3 equals 33. That's a fact. What are the two factors in that problem? Give me the two factors. Philip? 11 and 3. Because 11 and 3 are being multiplied. That's all we mean by factors. Okay, numbers that are being multiplied. And you can also say 3 and 11 fit into 33. Right? You can say it that way as well. All right. Here's my definition of the greatest common factor. Ready? My definition of the greatest common factor is this. The greatest common factor. That's my definition. The definition is the term. Do you get this word? Do you get that word? And hopefully you get that word. And then, okay, I get that. Because tomorrow, guess what we're talking about? Least. Tomorrow we're talking about least common multiple. Okay, there are two words that are different. Least is not greatest. Not the same, right? You guys get that? And multiple is not the same thing as factor. But what do they have in common? This is kind of funny. The word common. Common. Okay, all right. We're going to move on before I confuse people. All right. Let's see how to find it. So, to find the GCF, we're going to get a couple problems here. I'm going to work through two methods. One method is probably the one you're most used to. And then the second method, it was surprising that most students in the other class, and not all of them, preferred the second method. I was like, whoa, I thought that was good, but it doesn't have to be like that in this room. Okay, method one. So you can use this method on all these problems, and I'm okay with it. So don't feel bad if you use this one. You don't like method 2. I hate method 2, Mr. A. Method 2 didn't do anything to you, but I get it. Okay. Use prime factorization. All right, use prime factorization. So this is the one hopefully you're most used to. Okay, if I want to look at the GCF of, or if I want to find the GCF of 45 and 60, okay, two numbers. And I want to find the GCF. What's the greatest common factor? We can do prime factorization. Do you guys remember the factor tree? You guys remember how to do a factor tree? Okay, what two factors get me 45? 9 and 5. Are either one of these a, and here's a key word, prime number?
What's that?
Prime number. And you're like, wait, prime? Okay, a prime number as opposed to a composite number. Two categories of number, prime and composite. A prime number only has two factors, 1 and itself. So look at 5. You guys said that that's a prime number. What are the factors of 5? 1 and 5. So does it have any other factors? Whole number factors? Nope, that's prime. But what about 9? Prime or composite? Composite, because does 9 have 1 and 9 as factors? Yes, but it also has 3, which now we can break it down to 3 times 3. What do you think about 3, prime or composite? Prime, so they're both prime because the only factors of 3, whole number factors, are 1 and 3, so that's prime. Okay, I do need to review this because some of us are like, okay, I kind of get that, but which ones are prime and which ones are composite? I think in 5th grade, from what I heard from last class, you had this little sheet with numbers 1 through 100, and you had to find all the prime numbers, like cross out composite numbers, circle prime numbers. You had to go all the way to 100. I'm not requiring you to do this, but we are going to find the first few. Somebody raise their hand and tell me what the first prime factor is. It might not be what you think. So I'll correct you if I have to. Darius?
2.
Very good. It's 2. Now, how many of you are kind of thinking, wait, what about 1?
No.
Doesn't 1 have 2 factors? Wait, how many factors does 1 have? 1. Has 1 factor. It's itself. You don't do 1 times 1. Well, but that's the same number. 1 is a special number. Is it prime? No. Is it composite? No. It's neither. 1 is special. So the first prime number is 2. What's the next prime number? 3. The next one? 5. After that? 7. And then it's not what you think, but what's the next one?
11.
Okay, I think I heard a couple things. It's not 9, right? It's not 9. It's 11. Next, 13. Next, 17. Yep. Next, 19. Now, the reason I even went through that, maybe just to kind of do some drill. Yeah, you can get further, is because I want you to know, because certain problems might have those. You'd be like, wait, 17 is not a prime. 17 is prime. So you can use it. Okay, let me ask you this question. Is 27 prime? Raise your hand if you know it.
No.
Raise your hand if you know it. William? It's 27 prime. Why not?
9 and 3.
9 and 3. Boom. It already is off the list. Okay, 33.
11. No, 11 and 3.
Oh, okay. 31?
Prime.
Yeah. Sure.
Prime. And you're like, how do you know? You have to ask yourself, what numbers can give me 31? So, ready, guys? I'm a big person on math facts. You know, 0 through 12 math facts. Because if you know those math facts, you know a lot of the prime numbers or non-prime numbers or composite numbers. 51.
Yeah.
Can you think of any math? Okay, hold on. Can you think of any math fact that gives me 51? No. I got 50, 55, 54. Okay, so you automatically think it's prime. It's not prime. What number can fit into 51?
13.
17 and 3. So think through them. Don't just automatically think they're wrong. But we won't get too big too quickly. All right, prime factorization of 60. Sorry. What do you get with 60? What can you do? 10 and 6. Yep, that's a nice easy one. That is going to give me 60. Either one of these prime? Nope. So you can break it down further. 10 gives me 5 and 2. Oh, they're both prime, so I circle them. That means I'm done with them. I don't keep branching off of them. 6 prime numbers. Sorry, I was going to put 2, then 3. I reconsidered. All right. So those are prime numbers. All right, you guys good on that? Okay, so the prime factorization of 45, and you usually write from least to greatest, is 3 times 3 times 5. And the prime factorization of 60 in order from least to greatest, 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. Okay, ready? The word factor. What are these called? Factors. These are also called factors. Okay, so we get factors. Are there any common factors? Common factors. Yep, Alex?
3 and 5.
Yeah, so I just circle them just to distinguish them, the 3s and the 5s. These are common, right? They have the same. They both have 3 and they both have a 5. So the common factors are 3 and 5. You guys agree with that? So the greatest common factor is just multiplying those two common factors together. We get 15. That's my GCF. GCF is 15. Yes, sir? Now, let me give you a little disclaimer. That means let me give you some background to why we even did this. Some of you could do this in your head. That's amazing. Well, not super, because you've done this problem, even if you don't remember, about 4 times. This is like a super common problem. So if you can do it in your head, congratulations, you remember the answers. But if you can work it out this way and you can explain it to somebody, that's actually very impressive, because you get it. You really get it. Okay, so please use this method, because sometimes the numbers are 1,260 and 52. What's the GCF?
3.
Oh my. Oh, I'll give you some time. 1,260 and 52. Sorry, I made up numbers, but
1,260?
sorry? I was lost. Yeah. Okay, guys. A lot of us cannot do that in our heads. And if we do it in our heads, we probably don't get it right. But can you guys do it this way? If you broke it down to prime factors, you think you can go through that process? Yes, you'll be successful. All right, method number 2. Method 2 is a nice one. You can use either method. Oops. But you probably should know how to use both, but you can prefer one or the other. Use repeated division. Use repeated division. You're like, I hate this method.
No.
You're like, I don't even know what it is, but I hate it. Okay, let's see it first. Let's try it out. And then let's see what happens. Okay, so the two numbers are 45 and 60. And what? Yeah, I hope you know the answer now. So we're looking at this right here. We're like, okay, use repeated division. Now, I'm going to tell you a couple things. I'm going to do division upside down. You're like, why would you do that? Well, I don't know. I'll tell you in a while. I'm going to do division, and I'm going to divide by prime numbers. Okay, so if I know what prime numbers are, like 2, 3, 5, 7, so on, this will be very helpful. Okay, Mr. A, why don't you just do it the right way so you don't confuse us? Okay, think about it. You're working your homework, and you put this division problem, and you put it the right way. You're going to have to divide up, right? But this requires multiple steps, so you're going to have to go up again, and then up again. What happens if you're doing that on your paper? Think about it. What happens? You're doing your paper and you're working up. Yep.
You run into the problem.
Yeah. Wait. No, I got a curve. Got it. And you're just working around. No, work down. You have plenty of space. Yep. Okay. Then Mr. A, what are you doing? There are two numbers in that box. Yes. You're going to do two division problems at once. You guys are capable of doing it. Let's see if we can try it out. What prime number, any prime number that divides 45 and 60 evenly? Can someone give me one? Yeah, Hagen? 3. Does 3 go into both of these? Okay, 3 goes into 45? 15 times. And 3 goes into 60? 20 times. That's okay, 20 times. Okay, then I'm going to try that same question and ask, okay, what number divides into 15 and 20 evenly? Any other prime number? 5. 5 is a good one. 5. 5 goes into 15 how many times?
3.
5 goes into 20? 4 times. Okay, then I'm going to ask myself the same question. What number divides 3 and 4 evenly? Any prime numbers? Oh. Is 1 a prime number? Nope. Does 2 fit into both of them? No. 3? No. 5? Okay, you see nothing's going to fit. So here's a key word I want you to get. Ready, guys? I'm going to have you repeat it because I'm going to use it again. 3 and 4 are not divisible. That means they can't be divided by another prime number, right?
Correct.
So 3 and 4 are called, ready? Here's a key word. Relatively prime. Can you guys say that with me? Relatively prime. Now, I'm going to ask about that word or that term in a minute or so, and hopefully you can give it back to me. So 3 and 4 are relatively prime. So you are done with this division. And here are the prime factors that make up your GCF. 3 times 5 equals, that's the answer. That's your GCF.
Oh, I actually like this one. I like this one for the least common factor. I like this. No, I like it for the least common factor.
Okay, let me ask this question. We'll do it one more time, and then I'll ask the question which one you prefer. And it doesn't matter. If you like method 1, use it. If you like method 2, use it. But you should be able to think through both. Now, what I like about method 2 is it actually helped you to do something else we'll talk about in just a little bit with fractions, but we haven't gotten there yet. Okay, let's do one more. Let's look at the GCF of 56 and 70. 56 and 70. So just a little bit tougher, not much, but just a little bit. We're finding the GCF. So the GCF is going to be some number. It's going to be the, the greatest common factor of those two numbers. And I'm going to do it method number 2. If you want to do method number 1, I'm okay with that. Okay, what prime number can go into both of those? Think of your math facts. Think of a big number. It makes it easier for you. Yes? 2 does go into it? 7 goes into it. 2, both of them go. And Darius, you can go 2, and you'll still get to the same answer. Let's go with 7. 7 goes into 56? 8 times 7 goes into 70. Okay. And then Darius, what number goes into both of those? 2. So whether you use 2 or 7 first, still get the same answer, which is really nice. 2 goes into 8. 2 goes into 10. Okay, so I ask, can I divide those by any other prime number? No. Ready? 4 and 5 are, fill in the blank.
Relative.
Relatively prime. Who said that? Josiah, thank you. Relatively prime. Thank you, guys. So you don't divide anymore. You don't divide anymore. And method 2 is nice. These are my two factors. 2 times 7 equals 14. That's my GCF. GCF is 14. That's very nice. Okay, here's the vote. Cast your ballot by raising your hand. Do you like method 1 or 2? Method 1. You prefer method 1. It's okay. You like it. Great. Okay, it's good. You can vote for both. How many of you like method 2? Okay, listen to me carefully. It doesn't matter which one you like. You need to be able to do both. Okay, so if you do both, great. Okay, excuse me. I have a lot. I think allergies are starting to bug me right now. Okay, let's look at the next topic, which will be very close to the first. Simplifying fractions. All right, simplifying fractions. There we go. And I'm going to use, because of the input I got, I'm going to use method 2. But if you want to use method 1, I can show you that as well. So it's not like we can't do it, but just to save us maybe a little bit of time. Okay, we have a fraction here. Let's go with negative 14 over 42. Negative 14 42seconds. And we're going to simplify that. Now, before you even start doing that, don't do it yet. Some of you can do it quickly. Great. That's great. But we want to look at this way. Simplifying fractions means this. Look at this fraction right here. Is it simplified already? And you're like, maybe, no. How do you know? Okay, ready, guys? Here's our term. Look at the numerator, 14, and look at the denominator, 42. Are those two numbers relatively prime?
Yes. No.
So is there any number that can fit in both of them? If there's any other number than 1, they're not relatively prime. Therefore, this is not simplified. That's how you know it's not simplified. And let's use our method 2 real quick. You're like, wait, I thought method 2 and 1 were for GCF. Watch it. Watch what happens here. Okay, don't worry about the negative sign. You can put that at the end of your answer. That's what's cool about negatives. You can work this out and you're like, wait, is it positive or negative? Just put the sign that was there. It's negative. All right, what number goes into 1442? Prime number? Prime number. This will give us practice with prime numbers. But 14 does work technically. 7. 7 goes into 14. Twice. 7 goes into 42. Do those remind you of math facts?
Yes.
I hope so. What number goes into 2 and 6? 2. Once and 3 times. Okay. Does anything go into 1 and 3? Other than 1? 1 and 3 are? Awesome, guys. Here's my answer. It is not 14. That's the GCF, right?
Oh, this is 1/3.
With the negative sign. That's my answer.
That's right. Wait, what? Do this in our head.
No. Listen, a lot of like this problem, yes. Is it possible? Of course you could do it in your head. We do simple examples so you can do it to the harder problem. You can apply this to difficult problems. Simplify 260 over 512. Go. In your head. No paper. 260 over 512. Go.
In our head.
In your head. No paper, no pencil, nothing.
I'm not even going to.
No, it has to be a fraction.
3/7.
121.
1.
Oh, sorry. Are you still working on that problem? I fell asleep. Okay. Some of you can get it. Like it's not like beyond you. Like it's not possible. But you're going to either get it in a very long time, or you're going to work a very long time up here and not get it, which is sad, right? You do all this work. Quiet. Got it. Wrong. Or you work it out a very long time. Loading. Buffering. Got it. And you got it right. Or you could just work it out. Got it. Every time. Got it. Got it. Got it. Got it. Consistent. So, choice is yours. Yep.
Can you repeat that problem again? I didn't really understand why it's 1 and 3.
1 over 3. Do you get this part right here?
Yeah, I got that
Okay.
part. I just didn't get why it's 1 and 3.
So you see how 14 went all the way to 1 and 42 went all the way to 3. So 14 and 42 went all the way to 1 over 3. So this, you can almost think of it like a fraction, 1/3,
So,
which is really cool.
so we would
I can explain again on another problem.
So would we just do
Okay,
it this
sorry.
way?
I do need quiet. Go ahead.
So would we just do it this way every time there's a fraction, the other way when it's like a normal number?
Oh, I see. If you're saying find the GCF of 14 and 42, like two separate numbers, do that. When you're trying to find this fraction, do that. Because they both give you the answer, which is really cool. Okay, do this one, guys, on your own. And you show me the work. If you can show me the work, that's good. Simplify this fraction, 4/48. Mister, I can do it in my head. Congratulations. Now show me the work. It really doesn't impress me. It impresses me if you could show me why you get that and explain to your neighbor. And even if they didn't get it, wow, they get it now. That's impressive. That's really cool.
I got you 0.
Yeah, like, some things you should do in your head, like math facts, that's good. But some things like, I could do this in my head, Mr. A. Great. Show me the work. Yes. Do you have an answer, Hudson? I'm going to ask Hudson to tell me how he did it. Oh, sorry. Not yet, Hudson, but let's give him time. Method 1 or 2 is your... Okay. Yeah, I like it. At first, when I was preparing this lesson, I was thinking to myself, I wonder if they'll get that second method because it's not as commonly taught. So then I had to think it, but you guys handle it well.
We learned it before, we just needed a reminder.
Yeah, the hard part about method 2 is this. When you have big numbers and you're not really sure what prime number fits into both. But divisibility rules, you guys remember what I'm even talking about? Like, how do you know a number is divisible by 2 or by 3, even if they're huge? There are rules that you can say that's divisible by 2, that's by 3, 6, 9, all that. Yeah, both of them. 9, 7 has a rule, but that one's tougher. Yep. Oh, sorry. Do you have an answer or question? Question. Go ahead.
Okay, so I don't know if I did this right, but I got two different answers, not answers, but on method 1.
Okay.
So for 45 on method 1, we got the.
Oh, are you giving me answers?
No.
Okay.
The 5, 3, and 3 were the two prime numbers, or the three prime numbers, right? For method 1.
No.
For 45.
Mm-hmm.
And then on method 2, you circled 5 and 3, and that was it, right? Or I just missed that.
How about let me do both methods and let me see. Let's compare them. This is method 1. If you did prime factorization of 4, do you get 2 and 2?
Yes.
Hopefully, right? 2 times 2 is 4. 48 is 2 times 2 times 2 times 2 times 3.
Yes.
And if you don't believe it, sorry, that's it. And then, and then if you cancel out common factors, these are common. These are common. You have, don't forget, they don't just disappear. They stay as 1. What's 1 times 1? 1. What's 1 times 1 times 2 times 2 times 3? So you can get your 1/12, right? That's method 1. You could use method 1. Great, yep.
So I did method 2,
Okay.
and I got really confused because I had like 12, like other numbers could fit into 12, but like they couldn't fit into 1. So I wasn't really sure what to do.
Yeah, let's look at method 2. Hudson, how did you do method 2?
I put 4 here to 4 48.
Okay, and then you got your final answer, 1 and 12? Do you use prime numbers because you won't always know what numbers go into, but it's okay if you did, but give me prime numbers. What prime number goes into 4 and 48? So I'm making you do it a little longer, sorry. And actually, I did it upside down. Go ahead. 2 and 24. Give me another one. 2, 1 and 12. So is this what you got, Anna Grace?
Yeah, I got 1 beside 12. I just didn't know if I should keep going.
Yeah, you're like, does anything go into 1 and 12 other than 1?
No.
Nope. So that's your answer, 1/12.
4 goes into 4.
Yeah, that's what he did. Yeah. I'll show you why that could be a little bit iffy, especially if you're using Gcf, but that's okay for now. Thank you, Hudson. Okay. Sorry, I keep clearing my throat. By the way, in the summertime, I do not talk as much as I talk during the school year. So like at the end of the school day, I'm like, man, my throat is running dry. Like I can't talk as much. And then as the school year goes, I get my strength back. But summertime, I feel like I don't talk at all. I could just do my thing, point, grunt, but I don't talk. And now I have to talk, and that's harder. Actually, let me give you a little background. My son Titus, he's 1.5 years old, and he struggles with talking. Like he doesn't say very much. So we're actually going to give him some speech therapy. But the way I communicate with my son, this is my fault. And he goes, huh. And then, he totally follows me. I think that's cool, but I wish he would follow me when I say, Dad. And I'm like, oh, okay. No, he doesn't know how to say Dada. But that's okay. Hopefully he'll learn how to do that. But grunting was my main method to communicate with my youngest son. And then Ezra, God has really blessed him with being able to talk. This guy talks to me, and he's talking to me like a little adult, and I'm looking at him thinking, where'd you hear that from? Like, what? What did you just ask me? What did you just say? And like, I have to think about what he's saying because he's 3 years old. So, wow. Okay. Anyway, these two fractions. I'm going to move on before I get in trouble. These two fractions have the same value. These two fractions have the same value. How many of you agree with that statement? They have the same value. They don't look the same, but they have the same value. You agree with that? Somebody tell me why. There's a reason. There's actually many reasons you can give me, but give me a reason that fits. Yep. What do you think? Why? Okay, there's something to do with the greatest common factor. There's something really big with that, but what about it? Like same, yeah, but
Even numbers?
Okay, Sam, what do you think? They're the same, but why?
Because 1 goes in 12 times, and then 4 goes in 48 12 times.
Okay.
They both go into the bigger numbers the same amount of times.
Okay, let's go with this. Write your notes this, please. 4 over 48 equals 1 over 12. That's what you guys are telling me. That's what you're telling me. And the reason is because of this. Here's a property that when I introduced it and it used to be last year in 7th grade, but maybe you've heard it before. It's called the identity property of multiplication. Anyone ever heard of that? You're like, what did you just say? I get what multiplication is. Everything else, I don't know what you just said. The identity property of multiplication, and it's a cool identity because you use it all the time, and if you really understand it, you get more. Like you're like, and if this year you can ever point out to a problem and say, Mr. A, isn't that the identity property? My jaw will drop, and I will say, after I pick it up, wow, that's awesome. You know it. You know it. And in pre-calc, when they give you the identity property, you're going to be like, we learned that in pre-algebra. Yep. And some people in your class will say, I've never seen that in my life. Who do you think is going to do better? The people who understand it rather than those who don't. Okay, ready? Here it is. I'm going to start with 1/12, so I'm going to work kind of backwards, which is okay. 1/12 times your magic number 4 over 4 would give me what? 4/48. Oh, that looks familiar. So somebody tell me what the value of 4/4 is. What's the big value of 4/4? Henry?
1.
Oh, yeah. Wait, yeah, that's 1, right? Isn't a number over itself 1? Or is it 4 divided by 4, 1? Either way you think of it. Okay, what's any number, pick a number you have in your head, times 1 going to give me? The same number. What's any number times 1 going to give me? The same number. So we call these two fractions, and here's a key word you got to get, equivalent. Equivalent fractions. Maybe you've heard of it before, maybe not. But equivalent, do you guys see equal? That's talking about they're the same. Same value. Okay, let's look at the fraction 1/12 real quick. And I'm going to give you a trick question. Well, I don't know if it's a trick question. If it is, fine. If it's not, fine. How many equivalent fractions are there for 1/12? So one of them is 4 over 48. How many are there? There's an infinite number. I want you on your homework to give me 2 of them. 2 of them. Out of the, some of you might say bajillion. That's okay. I'll accept bajillion, billion, million. Just give me 2 of them. How do you do that? You do it like this. 1/12. 1/12. I want to give you one equivalent fraction. All you have to do is this. What if I multiply this by 8/8? Does anyone know what I get? Somebody raise your hand. 8/96. Listen up. This fraction is equivalent to the first. Why? Because you multiplied it by a big fat 1. That's the identity property. Any number times 1 is going to be the same number. That's what we mean by identity. Can someone give me an equivalent fraction to 8/96 that is not 1/12? So something here that is not to that. How'd you do that, Drew? What'd you do?
Multiply 2 to 1/12, and I got it.
So you did 1/12 times 2/2? One time, what'd you do?
No, yeah, 2/2.
2/2, yep. 1/12 times 2/2 equals 2/24. Are these two equal?
Yes.
Okay, good. Do you only have to multiply? Or can you do something else? You can divide by 1 and you get the same number. So listen carefully. Here's the identity property, like a sidebar. Any number divided by 1 equals the same number, right? Is that true? So you're like, but Mr. I can think of an example. 50. Well, what's 50 divided by 1? 50. So it works, right? So if I had 8/96, what if I divided this right here by, so I'm dividing this one by 2/2. What would I get? 4/48. Oh, that looks familiar. These are all the circled fractions are all what we call equivalent, have the same value. If I give you this fraction, all I want is for you to give me 2 other fractions. So I gave you 3, just give me 2 others. Does that make sense? You can multiply or divide by the same number. Okay. Let's go here. Did someone say I'm confused? Okay. Can you ask a question? I don't mind. It's okay.
What?
How about this? Let me go to the next type of problem you'll get. Okay, listen carefully. This is the type of problem you will get. I want you to tell me what the value of n is. Hint, hint, it's up there. But I want you to find the value of n. First, you have to understand, because I'm giving you an easy one right now. Listen, these two fractions are equivalent, but how do I know that they're supposed to be equivalent? I don't even know what n is. They're equivalent because there's a certain little symbol there, Andrew. Philip? There's an equal sign. So what does that tell me about these two fractions? They have to be the same, but they don't look the same. What does n equal in this problem? How do you know it's 4? Go ahead, Andrew.
If you do 48 times 8, you get a certain number, and if you divide that by 96, you get...
Okay, that's cross multiplying. Yep, you could do that. 8 times 48 divided by 96. What's another way to do it? And this will hopefully help out most of you. We'll get to cross multiplication.
So you could divide 48 into like 96.
So we'll divide right here. So we'll do divided by 2. So if I divide that,
Divide by 2 and then
what do I get? My 4. You guys see that? You can divide or multiply to get that missing number. Okay, and hopefully you guys know how to do that. Last little part. And then I'm done. Yeah, it is warm in here. And I haven't had anything to eat in like 40 minutes. Okay, let's finish this up. Last part. Okay, yeah, we'll be done. Please write this in your notes if you're following along. Writing decimals as fractions, and I'll put here or mixed numbers, because sometimes your decimals can become mixed numbers. And this is the last concept we'll go over. Last one. Okay, writing decimals as fractions. Yes, sir.
Is the quiz on everything we've learned?
Like everything?
like far.
Oh, everything's so far. Like to this point?
From like the first two schools to this point.
So all the way back to the first day, all the way to here, like all that in between? Oof.
Yes.
That's a good question.
Here, why would you?
It's 1-1 to 1-5 for you guys. So it's...
But we're only
Is
on
that it?
1-3.
Yeah. Yeah, so that's on next Tuesday. Yeah.
Yeah, so there was something that we learned.
Yeah, so not yet. We're not there yet.
Well,
Okay, let's finish this up. Let's finish this up here. All right, I'll wait till you guys are done. Okay, negative 0.35. Now, when we normally read decimal numbers, we tend to say negative 0.35, and that's not bad, but what's the proper way of naming this? Well, when I'm trying to write decimals as fractions or mixed numbers, the way I say it is super helpful if I say it correctly. Who could read that decimal number properly? Like I want the exact name of it. It has a specific name based on how it's written. Michelle?
-0 and 3,500.
Okay, you could say -0 and 3,500, or you could just say negative 3,500ths. But how in the world did you get? I get 35. Everyone get 35? Where'd you get hundredths? Like, where's that at?
On a number.
What's the last place value of this decimal number? Hundredths. So we would write it, here it is, negative 35 hundredths. That is the fractional version. If you could say the name correctly, you can get the fraction right away. So how do I write a decimal as a fraction? Just say it. How do I say this again, guys? Negative 35 hundredths. It's right here. Isn't it? Right? Yeah, you can say negative 350 thousandths, blah, blah, yeah. So we're not going to get that far. But is that my final answer?
No, you're not.
Ready, guys? 35 and 100. You can ignore the negative for now. 35 and 100 are not, fill in the blank, relatively prime. So then you can divide them out and you can get your final answer. Oh, time is my worst enemy, maybe your best friend. Listen carefully because I won't say this twice. We are not done. I would have had one other example, but time is up. So listen carefully. If you're not listening, I can't give it to you. There is no homework tonight, but don't expect this every night. It's not happening. It's just we ran out of time. Put your books back and let them come in. You can come. Put your books away. You can. Bye bye. It won't happen all the time.